Okay, we're going to construct an altitude here to begin with. An altitude is a line segment that goes from a vertex of a triangle to the opposite side, and it's going to be perpendicular to it. That's important. And we start by putting our compass point on the vertex that we're interested in. We draw a line that intersects the opposite side in two places. Now, we might have to extend the side in order for it to hit in two places. In this case, I didn't have to, but you might have to. Okay, and then I'm going to cross my arcs down here and down here. So it's a basic perpendicular construction. And this segment here, perpendicular to the side going through the vertex, is an altitude. Okay, altitudes are important when we want to go to calculate area, because the formula for area of a triangle is 1/2 base times the altitude. So we need to know altitudes for that. Now I've just done one of them, but if I construct all three altitudes to a triangle, because each side can be considered as the base, okay, you notice that the three altitudes all meet in the same place. Okay, so here's side BC and here's the altitude to it, AF. Here's side AB and altitude DC, and here's side AC and altitude EB. Okay, the nicest ones to look at are when the triangle is acute and all the altitudes are inside the triangle. If we end up with an obtuse triangle for some reason, then our altitudes are going to fall outside the triangle, which is a little harder to look at. So you see, if I've got dotted lines to extend it, but it's still, AF is still the altitude to side BC, even though it doesn't actually hit the side, but it's perpendicular to the line that contains that side. So you can see, if I extended line BC, the side BC, then AF would be perpendicular to it. In the case where, if I move the side a little, watch angle C as I do this. As I try to do this. Okay, angle C is becoming closer and closer to a right angle. When it becomes a right angle, then the altitudes are the same as the sides. So that's a nice special case to look at. Okay, so since these are used in area, let's look at some properties. If I take the measure of side AB and the measure of its altitude, DC, and I multiply them together, then I get that, okay? If I take side AC, or CA, and the altitude to that, EB, and when I multiply those two sides together, I get the same number as I had before. So same thing's going to happen with the third side. If I take the measure of side BC and its altitude, AF, and I multiply them together, I'm going to get that same number. So when we're going to work with areas of triangles, it's not going to matter which base and altitude we use. It's always going to come out the same, no matter which case we use. And you can see if I change things up a little, my products are still the same. So that's the altitudes of a triangle. And the place where they meet is called the orthocenter.